All right, example 28a says, the sum of the first three numbers of a convergent geometric series is 21, and the sum to infinity is 64 over 4. So a couple of things, you're not allowed to write your number like that. It must be a fraction. Forward slashes are a no-no. Determine the first three terms of the series. Okay, so we know we're dealing with geometric. Okay, geometric. So if we're doing geometric, what are the formulas that we know for geometric? We know that we're doing sum of, okay, so there's no TNs here. The Sn of geometric is a fraction, which is a, open bracket. Now, because it is convergent, and this is where this convergent work now comes into place. Remember, geometric has two options. It can either be Rn minus 1 or 1 minus Rn. Do you remember the definition of convergent? Convergent says that x is between 1 and -1, which means that when it's convergent, we're always going to put the 1 first. We always, Rn is always going to be smaller than 1, so it's always going to be second. So what do we input here? 1 minus Rn, and I just want to repeat, we're doing 1 minus Rn because it is convergent. That word convergent is what makes us choose to put the 1 first. Then we got 1 minus R, and our second information or second form or equation is going to be the sum to infinity. So S infinity is equal to A over 1 minus R. Those are the two equations we're going to use, right? What other information do we have? We know that the convergent one equals 21. Oh, well, that's S3. Okay, let's write this separately. Okay, so we're going to say the sum of three terms equals 21, and the sum to infinity equals 64 over 4. That's the information that we are given. The question is, what is term 1, which is also A? Hold on. This is a series, which means we're doing addition, right? Not a sequence. Plus, what is term 2? Plus, what is term 3? This is the question. What is term 1? What is term 2? What is term 3? So let's go ahead and deal with our two equations. Let's first deal with the first one. So we're going to say this S of n is equal to A 1 minus Rn over 1 minus R. The S of three terms, we know n is 3 based on this, is equal to A 1 minus R to the power of 3 divided by 1 minus R. And this is equal to 21. Okay, that's as far as I can take this one. Now let's look at B. So for B, we are going to input the S of infinity is equal to A over 1 minus R. And we know that this one is equal to 64 over 4. Now, I want to do some form of magic, right? Not magic, mathematics. And what I want to obtain is similarity, because if I have things that are similar, I can get rid of them, right? So I'm going to base my decision on what to do on this one. There's not much movement I can do here, but can I manipulate this to look like that? So what am I looking for? I want A as a numerator. Yes, I got A as a numerator, A as a numerator. In my denominator, I want 1 minus R, 1 minus R. So what do I want to do? I want to get rid of this portion here. And since it's a numerator, what I will do is I am going to multiply or divide. I can multiply everything by 1 over 1 minus R to the third. So on the left-hand side, it cancels out. And on the right-hand side, it goes in the denominator. So my new line is going to be A over 1 minus r, which is exactly what I want, is equal to 21 over 1 minus r to the power of 3. Okay, great. This looks good. So I put that in bracket. I'm going to name this one A, and I'm going to name this one B. So far, so happy. Wait, let me double check. Okay. So I think I typed the question wrong. This is supposed to be a 3. So change that and that and that to a 3. It's 64 over 3. My apologies. Okay. So what do you see? You see that you've got A on the top and your denominator is exactly the same, which is 1 over r. And since these two are the exact same thing, I'll write it over here. A over 1 minus r is equal to 64 over 3. This is B. Now, since these two are equal, if this is equal to each other, that means this is equal to each other. And so I am going to take the right-hand side and make an equality statement. And I am going to say 21 over r minus, so, no, wrong way. 1 minus r cubed is equal to 64 over 3. And that equality statement is based on what we did by making the left-hand fractions identical. Now we can solve for r, because over here I have one unknown, and that's just r. So let's go ahead and multiply. Let's get another blue here. So I can now say 21 equals 64, and I want to get rid of my denominator, so I times 3 here to move it to the other side, and I times 1 minus r cubed over here. So this is good. Now I can simplify. 64, this gives me 63, if I'm not mistaken. 63 is equal to 64 minus 64r cubed. What happened here? Distributed that in. Here I just multiplied, right? Okay, now I've got 3 terms, one on the left, 2 on the right, but I've only got one variable. So what I'm going to do is I'm going to take this to the other side. Plus 64, the opposite of that is minus 64. 63 minus 64 is negative 1 equals negative 64r cubed. Okay, let's get rid of that 64. So we want to get rid of this, including the negative sign. I am going to, this is multiplication. So I'm going to divide by negative 64. And what happens on this side? Okay, let me do it. 64. Minus and minus cancel. This whole thing, minus and minus cancel, 64 and 64 cancel. On the left, I have 1 over 64, and that is equal to positive r cubed. So far, so wonderful. Now, let's go ahead and do our cube root on both sides. So when we cube root that, we are going to end up with r is equal to, okay, cube rooted, and we end up with 1 over 4. Now, on our cube root, we're not going to have a plus minus. Our cube root will only work on if it's an even number, we have a plus minus result. So now we have an answer that says r is equal to 1/4. Do you remember what we're trying to achieve? Yes, we're trying to get term 1, term 2, term 3. We have r now. So now we need to solve for a. So you can choose to substitute into a or into b. Now if we look at a and we look at b, a is more complicated because it's r to the power of 3, whereas b is simpler because it's r to the power of 1. So I'm going to choose to substitute into b. And I'm going to say, okay, let's substitute R equals 1/4 into B. B is A over 1 minus R equals 64/3. And I substitute, I get A over 1 minus 1/4 equals 64/3. Now I can solve the denominator if I want to, or not. If I don't, you can just keep it the way if you want. But okay, let's solve it. A over -3/4, because 4/4 minus 1/4, 64/3. Now we want to get rid of that denominator. So what are we going to do? We are going to multiply, right? And the way no, it shouldn't be negative. 4/4 is positive. Okay, so let's multiply the whole thing times 3/4 so that the denominator cancels out, right? So then we're going to get A is equal to, and all you have to do is put in 64/3 divided times 3 over 4. But I just want to point out on the screen, you can cancel. You can cancel the 3 with the 3, numerator and denominator. So you got 64 divided by 4, which gives us 16. In other words, our answer is A equals 16. We've got our A, we've got our R. Let's now try to solve what they're asking us. Term 1, A, is 16. Term 2, now which one do you want to use? It's entirely up to you. What is the term formula again? So this will be now the part where you're doing the term formula in order to solve, because now we want term 2 and we want term 3. So the TN formula for a geometric sequence or series is, hold on, it's A R n minus 1. So we are now going to say term 2 is equal to A, which is 16, okay, for both of them, 16, multiplied by R, which is 1/4 for both of them. And the exponent is going to be 2 minus 1 and 3 minus 1. So input that. Sorry, let me grab my calculator so you can see. So we're going to input here 16, open bracket, 1/4, sideways close, exponent 2 minus 1 gives us an answer of 4. So the next term, term 2, is equal to 4. And I can go back here and delete that. 3 minus 1 is equal to 1. So term 2 is going to be 4. And term 3 is 1. Your answer is 16, 4, 1. Or 16 plus 4 plus 1. Now, which one? Is it with the pluses or without the pluses? Plus infinity or semicolon infinity. Okay, so that is example 28a.